Okay, I think that's a lot of people coming into the meeting, so we will get started. Hello everyone and welcome to Reuters Events Oil and Gas's latest webinar, Composite Analysis Extending the Life of Offshore Assets, sponsored by ABS Group. My name is Charlotte Howlett and I'll be facilitating this webinar alongside our panelists from ABS Group, who I'll introduce shortly. As you may know already, I'm Head of Oil and Gas at Reuters Events. This webinar is one of several pieces of work we're doing to promote the industry and some of the key issues within it. There are over 500 of you signed up today, so thanks so much for the great response, and thank you in advance to our panelists, Aaron and Vastan, for their time. Just a brief bit of housekeeping before we begin. This webinar will last for approximately 50 minutes and is being recorded, so we'll send you the full audio recordings and presentations via email following the session. You also have the facility to ask questions through Zoom, so please do use this function to interact with the panelists and gain maximum value from the session. We'll also have some live polls as we move through, so we will encourage interaction kind of in all formats. So, without further ado, the purpose of today's session is to take a closer look at some of the solutions supporting asset life extension. During the next 50 minutes to hour, we will hone in on a number of areas, including the benefits that composite repairs can bring to offshore asset owners. Discussion will include cost-optimised asset life extension due to no hot work permits and lost production due to shut-in, the limited impact on deck load capacity related to little change in the centre of gravity for floating vessels, and increased saltwater resistance due to the non-metallic nature of composites. Joining us today to address these key issues are two experts in the field. Vastan Tchokoev, Director of Business Development at ABS Group, and Aaron Kline, Senior Director of Engineering and Risk Management at ABS Group. Without further ado, I will hand over to Vastan and Aaron to introduce themselves and ABS Group in a little bit more detail, and we'll move forward with the session. Vastan,
I appreciate it. Thank you so much, Charlotte. And thanks everybody for joining us today. So my name is Vastan Tchokoev. I lead business development for ABS Group, and I'm particularly happy to be here today. And my background is, just to give you a little bit, is my degree is in civil engineering. Goes back some years ago, back to 1996, and I did focus on materials and structures. So I have a little bit of background. I took a few classes, though I wouldn't call myself an expert, but I do have some background in composites. And then over the course of most of my career, starting in the late 90s, 1998, I've predominantly been working in offshore and energy most of my career. And through those years, I have focused on bringing pretty much new products and services into market. And this would be my latest endeavor, is trying to bring in some novel new technologies, such as this UNDE, to help facilitate the use of composites on a greater scale in our industry. So I appreciate your time. Thank you so much. Aaron?
Yes, good day, everyone. My name is Aaron Kline. I'm the Senior Director in our Risk and Reliability team. My background is operations as far as offshore oil and gas services company, and also marine services company and logistics. So kind of a blending of both the offshore and the marine aspects, where composite repairs, of course, are in use and are very common, and also in the production element as well. So greatly appreciate you guys joining us today. And I think you'll learn a little bit of something from Vastan and I, but hopefully we kind of generate even more questions, which is really the purpose of this webinar, is to kind of field your questions and answer those, and then be able to kind of act upon any issues that you guys are having, kind of understand your pain points. So looking forward to the session. Vastan?
Sure. Yeah. And so just a little bit about ABS Group, just in case you're not aware of who ABS Group is. We are a subsidiary of our parent company, the American Bureau of Shipping, and we actually do a lot of work in the areas of engineering, consulting, as well as risk and reliability. And so there's a lot of different areas that we're involved in, and this being one of them in terms of the actual offshore industry and supporting it. And in this case, we're going to be focusing on UNDE technology today.
Fantastic. Thank you, Vastan. The screen is now shared, so yeah, you'll feel free to move on with the presentation.
Okay, perfect. So on this first slide here, I have to tell you, I had to do a little bit of research and on this first bullet point. So one of the things I'm trying to show you here is, where have we been? How did we get to where we're at today in terms of looking at this unique UNDE technology for finding defects in composites, in particular composites used for offshore applications, marine and offshore. And one of the things that was interesting to me when I did the research is I was looking at what qualifications, what other types of NDE technologies have we looked at, and how far back could I go? Specifically, I was looking at offshore applications, and really I couldn't find anything that dated much earlier than the last decade. But when you go back into the early 2000s, it was of interest because it appears that there was quite a bit of research in this area with different research institutes, including one of my previous professors, Dr. Don Bray, that was working with NTIAC at the time. And they were doing quite a bit of research into looking at not just the ultrasound, but looking at X-ray, thermography, acoustic emissions, and a lot of the other traditional, I would say, NDE technologies that we've used in manufacturing a steel pipe and for years, and looking at welds for better than, I would say, 50 years, 60 years in many cases. And so really the early 2000s was the first instance that I could find where there was really any study that compared all these technologies, almost 12 different NDE technologies, to one another. And the thing that I noted was that at that time, each one of the technologies had certain things that it could detect or pick up within the composites, but it couldn't see everything. And so there was still a lot to be done. And at that time, ultrasonics was considered. And so if we fast forward a few years, the next key milestone that I noted is 2006. And one of my former colleagues, Dr. Chris Alexander, he had told me that probably some of the research work that he had done in relationship to some work for the composite repair of risers for the offshore industry was probably some of the initial, if not the first, research funded work, at least in the United States, in the Gulf of Mexico, that really pertained to composites being used in an offshore application. And so 2006, we're talking about 15 years ago, was really the first time that the industry, at least in the US, really considered using composites on a much larger scale for offshore applications. So I wanted to make certain that that was duly noted on this timeline. And then if you look, you're really almost going more than a decade then to where you finally have a company, in this case, it's the Aerospace Corp out of El Segundo, California, that actually developed a technology, not for our industry, but for the aerospace industry. They actually had a challenge presented to them several years ago by NASA, where they were tasked to develop some type of an NDE process that would be able to find defects in the heat shield, which are made from composites for the Orion space capsule. And so, that was really kind of the first time that we've really seen a technology advance from where we were in the early 2000s, almost 20 years prior, to a point where we actually have something that we feel can be commercialized for offshore applications today in finding defects in composites. And then, of course, 2020, the reason I put that date on there is I think it really signifies where the industry is today. I think, the industry today really wants to use composites on a much grander scale. And a lot of that's driven, let's be frank, by the last 6 years. We've seen the depressed oil prices, where it's really forced a lot of the oil and gas companies and E&P companies to really look at their assets and consider how much more how much can I extend the life on these assets, these floating production platforms, and even the fixed platforms. And so what that has really pushed the industry towards is, what can I do in terms of life extension, and what technologies out there allow me to do that on an economical basis? And composites is one of those solutions. potentially. And so in 2020, our parent company approved the use of composite repairs for one of the major FPSO operators in the world, for the basically the strengthening of the hull on one of these floating production vessels that can be used across the world on all floating production structures. So that to me is of significance there, because once again it shows the industry is ready to use these on a much larger scale than where we have previously used them for. And then of course 2021, the significance is that it's basically we're at that point now with ABS Group in commercializing this, and we've already done preliminary validation testing to show that this technology does have the ability to find defects and flaws in these composites over the life of the composite. And so having said all that, the only thing I would leave you with is that, with this technology in its infancy, I think we're really at a breakthrough point here in the industry in being able to, for the first time, really understand how composites perform over an extended period of time. And it looks like we have a question. And let me ask it here. It says, has anyone looked into land reclamation expanding from offshore structures for agricultural use, recreation, and tourism? Obviously this technology, it can expand beyond the offshore industry. I don't know for a fact if anybody has looked at it for the land reclamation, but certainly I would think that there's got to be some other possibilities, and I think if I understand your question, this would help to eliminate and possibly help these composites being used on a much longer period of time, so that way you wouldn't find them in landfills or being used, or being disposed of in that matter. I'm not quite sure I understood the question, and if I didn't answer it properly, then please feel free to re-ask the question.
Fantastic, thanks, Vastan. No, that's marvelous, and I think what would be really good, and actually kind of based on kind of a couple of the questions coming in, it would be a really good idea to get an idea of kind of the backgrounds of our audience and how much of our audience have kind of considered or tried composite materials for repair. So that will lead us actually on to our first poll question. What I will do now, I will launch our poll question. So if I could ask the audience to vote on the poll question. So within your role, have you considered or tried composite materials for repair? We'll give the audience kind of 20-30 seconds to vote, and yeah, then the panelists will be able to see.
And while we're waiting, there is another question that just popped up from James Finley. How do you plan to integrate your UNDE technology with the defect tolerance assessment to help with life extension? And that's a great question. In fact, actually, we're working with our parent company, the American Bureau of Shipping, that has a guidance document out there right now since the end of 2019 for composite repairs for the offshore industry. And so one of the primary questions and how to address that is, looking at, defining what the acceptable criteria is for each type of defect for every type of application. And so we're right now working through that. How do you structure that? Should you structure it through a GIP? With all the industry, the operators, and composite repair manufacturers, including regulatory bodies involved. So we are actually working through that right now, and you're absolutely correct. That is something that that we feel that is the next step for the industry. Is with this technology, for the first time, we will be able to define what that set criteria looks like. So absolutely agreed, and we are working to get to that point.
Fantastic, thank you, Vastan. So what I will do now, I will share the poll results with the audience. So the question, within your role, have you considered or tried composite materials for repair? So 47% of our audience, yes, they have. 53% of our audience, no. So it looks like we've got quite a mix there. Was that kind of what you were expecting in terms of the audience of the webinar? Are there any comments that either Aaron or Vastan would like to make on that?
No, I expect it to be fairly almost a 50-50 split, I think. I mean, based on my previous conversations with operators and others. I mean, it's like anything else. I mean, it depends on the risk tolerance of the operator. I mean, some operators are going to be prone to taking, a little more risk and using, maybe being the first to use some new technologies, where others may, hold off until they feel that, the criteria, like the previous question that just came up, do you have the actual standard, the criteria for the acceptance of a defect? So, some people are going to be a little more hesitant, I think, to use the technology. So I don't think this really surprises me, but I think it's actually encouraging too, because you have 47% that have replied that they have used composites at some level.
Yeah, and I think also, Vastan, you brought up the risk tolerance of the actual operator stuff, but also it's still, you need to bring along the regulators and all the, government bodies and the U.S. Coast Guard, in our case, in the Gulf of Mexico. So, getting buy-off from the class societies and the regulators and the other government agencies can take some time as well. And you really need to, perfect the technology and understand, like Vastan was saying, the limitations and also to understand what is considered good and what is considered a failure and needs to be redone. So all that work needs to take place at the same time. So I'm not surprised at all.
Yeah. Fantastic. Yeah.
Yeah, and it looks like we have a few more questions here. If you don't mind, Charlotte, I'll try to answer a few more of these. So we have Dennis Karachkin, if I'm pronouncing that correctly. And his question is, what is the history, if any, of using the composites to perform repairs for Arctic onshore? It's funny that you mentioned that, because we were trying to go through a bunch of these questions yesterday in preparation, and talking with some of the scientists that developed this technology, and in some of the validation tests that we're preparing. And I told them, I said, I don't know that we're going to have a lot of applications for this in Arctic regions. So the answer to your question is no, we haven't yet. But now it appears that we need to take a serious look at that, because one of the questions comes in, or what one of the potential issues would be with the gel. Obviously, we're using UT here, so that transducer head, you have to have some type of a medium. And so those gels that we typically use, if it's freezing out there, that could be problematic. So we're going to have to look at maybe a heated head and keeping those gels in a solution state and not allow them to freeze up. So there are going to be, I would say, some hurdles. I wouldn't call them insurmountable, obviously, but there are going to be some things that we're going to have to do if we're going to look at applying this in Arctic regions. But I would say that would be something that we would be interested in tackling, but we haven't yet. The next question it looks like we have here is also from, in fact, Dennis has many questions here. ESP, interested in drilling rig repair applications? Yeah, absolutely. I think there's definitely some applications there. With the drilling rigs, personally, from what I've seen so far, most of our interaction has been with the operators, and they're looking at. We're going to get into it here in the next slide that Aaron's going to discuss. But you'll see there's several applications that we've discussed with the operators. None of those have been drilling rig company. So I would assume that there are applications there as you're asking for, but we have not had direct engagement with any of the drilling contractors as of yet, and would certainly be, very, happy to have those engagements. Let's see, next question. Sorry, there's, let's see here. The next one is jumping down here. How do you plan, and this is, let's see here. Oh, I'm sorry. This is from Tushar Padar, if I hope I'm pronouncing your name correctly. What kind of composite materials are being discussed? Metallic alloys, carbon fiber, or polymeric? So right now we have validated the technology for e-glass and carbon fiber. I know there's aramid. I know there's other types of composite matrices that you can use with the epoxies and the polyurethanes. But typically, everything up to this point has been an e-glass carbon fiber with an epoxy or polyurethane as the bonding medium. And now, as far as the metallic, and we'll get into a little more detailed discussion in a later slide, but we are looking at trying to use this technology not only to read through and find the defects in the composites themselves, but also the steel substrate underneath the composites that are being overlaid. And we'll talk about that a little bit more later. Let's see, what else here? From Zhenjing Zhu, what is the highest temperature your composite products can be used for onshore, offshore assets? You know, the composites themselves, we are not the manufacturer of the composite technology. So that's not really a question I can address. I can tell you the equipment itself, that is the UNDE technology that allows us to find the defects in the composites. The way that we have it structured now is it will work in all applications around the globe, except for possibly right now Arctic conditions. So anything above freezing, we should be fine to use the technology. As far as the actual composites, that would be a question for the manufacturer of the composite technology. And I'm sure they would be more than happy to answer that question for you. Let's see here. And then the other one is, and I think we already answered this, from James Finlay. How do you plan to integrate with, yeah, so we've answered, I think, that one. And then you have another one here, Roshan Amisur. How does this NDE technology work? Can it detect all types of defects, including interfacial delamination? And how good is it through CFRP carbon fiber? So yeah, so right now the actual technology itself, so there's probably easily 20 plus different forms of waves that we can integrate into our system. Right now, we've been very successful in just using basically longitudinal waves with our UT transducers, and they're able to find, and we'll get into this in more detail in the third slide, but we can find all types of defects, everything from inclusions to disbondments or delaminations. And the nice thing about the technology is it traces a very accurate representation of the size, shape, and the depth of that. So it's very detailed, and it's all done in real time. And we'll talk about that in more detail in the following slides. It says, I guess your main, and this is from Wesley Silva, I guess your main goal is to measure the wall thickness by UT. Which technique do you recommend to inspect the composite layers? Okay, so that's what we're talking about here. It's not so much the wall thickness of the steel pipe, though eventually that's where we believe that we can get to. Right now, we're really talking about the thickness of the actual composite itself, and looking at each one of the layers of the composite, whether it's carbon fiber or e-glass. So we can measure through several inches actually of composite, multi-layer composite, and homogeneous, in that case, homogeneous composite or plastic. So the technology is actually very capable in that area. And we can get into that in a little more detail, I think, in the third slide. Let's see here. What software? This is from an anonymous attendee. What software is suitable to model composites for offshore structures? You know, this has come out multiple times. So I know that some preliminary discussions we had was, can you take that the actual live data feed after we processed it in real time, and take that information and directly upload it into any FEA software, Abacus, ANSYS, whatever you're using. And currently we cannot. Now, ultimately, that is where we want to take this technology, is to be able to do a more an easier transition from let's say the direct output that shows you where your defects are, and bringing that, or making it easier for you to upload it into FEA. Currently, what you would have to do is you would have to take the output that we provide, and then you would have to recreate that size, the defect in the actual FEA software itself, to be able to get a better understanding of what the detriment is to your overall, you know, the fatigue, you know, the structural integrity and possible impact to your fatigue damage rate over time. So great question.
I think we may want to move forward in the
yeah, I'm sorry. It may
actually answer some of the questions.
Yeah,
so yeah, Charlotte, you never know.
I'm sorry, you'll need to tell me to stop. So I mean, I think these are all great questions, and I apologize because I'm looking through here, and unfortunately, I think we probably need to push forward. So Charlotte, I'll allow you to bring back up the presentation. I'm sorry, because I could go on all day.
Yeah, no, that's not a problem. That's not a problem at all. So that leads us into our second poll question. So I will launch the poll question now. So this question, if the audience were able to vote, that would be fantastic. So how much do you rely on class society guidance documents in support of your decision in using composites? So do you significantly rely on the guidance documents, somewhat rely on the guidance documents, only occasionally rely on the guidance documents, or don't rely on the guidance documents, or you're not aware of them? If the audience could vote, that would be fantastic, so we can get an idea of I suppose of how much guidance documents are utilised within the industry, granted that that only around 50% of the audience, half and half, are using composite repairs at the moment. So I'll just give the audience a moment or two to vote. Do a couple more seconds. And
see, Vastan claimed he wasn't the subject matter expert on this, and obviously by his answers.
Fantastic. Okay, awesome. So what we've got in terms of the results, I hope that you two can see them from your end. So we have 41% of our audience significantly relying on guidance documents, 28% of our audience somewhat relying on documents, 11% on occasionally relying, and 20% don't rely on the documents or in turn aren't aware of them. I'm not sure if Aaron or Vastan, you kind of have thoughts on that. I mean, I'm not sure how kind of really critical you feel they are from your end. I'd be interested to hear your thoughts.
No, I honestly think this is encouraging, because when you look at the guidance documents, they've only been out there for a few years now, and they're obviously a work in progress. They're still, like, we said before, as far as listing out the, the types of defects or the size of defects and those types of specs, I think those are still to be included. But no, this is encouraging. I mean, the fact that you've got, about 41% of your, respondents showing that they rely on the guidance documents, and if nothing else, the other 20% that aren't even possibly aware of them, and now they are. So I think, that's, always try to look at it from a positive perspective.
Fantastic. Sorry, Aaron, did you have anything to add there?
Nope, not at all. I think what we talked about earlier too is the guides documents are good until the point that they ask, okay, what's a good defect, and what's acceptable and what's not acceptable, right? So without that information, it's tough. It's tougher than to really rely on those guidance documents. But and that's what we're kind of pursuing, is to work with the class societies to update those. Yes,
certainly. Certainly. No, fantastic. Well, that's great. So we're back on the presentation now. Vastan, Aaron, we can move onto the next slide. I know we've got discussion questions there, but equally I'm aware that we've got already a lot of audience questions. So I mean, from the audience perspective, that's great. Please keep them coming, and we can get to more at the end. So without further ado, we'll move on to the application slide, and I'll hand back over.
Yep. Thank you, Charlotte. Offshore industry is moving to more widespread use of composite materials and techniques to repair corrosion damage to offshore platforms, such as wet overlay on steel. For this reason, a non-destructive inspection process is required that regulatory bodies, class societies, and other government entities can validate for determining the reliability of the composite repairs pursuant to existing standards. The benefits of composite repairs and a UNDE inspection process for the offshore sector include ability to transform temporary non-structural composite patch repair systems into a more permanent repair solution by establishing the defect acceptance criteria, which we discussed earlier. Extend the life of vessels at a lower cost, since there are no hot work permits required for the repairs and no lost production due to shut-ins that may be required during the repairs. And the composite repairs keeps the center of gravity low on floating structures when compared to traditional steel plate overlay and reinforcement methods. Similarly, the marine industry is ever changing. Manufacturers of yachts and other vessels utilizing composite hulls are looking for ways to improve the quality of their fabrication processes. In addition, 3- and 5-year inspections are currently required by class societies such as the American Bureau of Shipping. These inspections can be tedious, would benefit greatly from the UNDE technology in terms of efficiency and defect detection. Specific examples of applicable services for the UNDE technology include a global energy company and a pioneer in deep water offshore production in collaboration with a composite repair provider, are interested in qualifying the UNDE technology to check for defects in composite deck repairs. Also, federal regulators have asked for suitable means of inspecting the composite repairs over the extended life of the facility. Also, a global supplier and operator of floating production storage and offloading facilities, in collaboration with a service provider, are also interested in qualifying the UNDE technology to check for defects in composite repairs that utilize a vacuum-assisted resin transfer molding technique for carbon fiber. This process is designed for ballast tanks specifically, but can also be used for deck and other structures susceptible to corrosion damage. National Oil Company, one of the world's largest deepwater offshore production companies, in collaboration with a composite repair provider, are interested in qualifying the UNDE technology to check for defects in composite repairs of piping systems. Local government regulators have also asked for suitable means of inspecting composite repairs over the extended life of the facility. And finally, a recognized world leader in the design and manufacture of luxury yachts is interested in qualifying the UNDE technology to replace current through-port inspections, which can be very tedious and labor-intensive. So this is actually removing brass fittings that are penetrating the hulls of these luxury yachts. So, there could be machinery and piping and other components in the way for these inspections. So working with the applicable class societies, the intention is to qualify the UNDE technology for the inspection of these through ports and composite ship hulls, resulting in a revision to the current class inspection protocol. So if we can lower some of those inspection timelines, then the owners of the yachts won't have to, pull them into a shipyard, dismantle half their engine room just to get to these fittings that go through the ports or go through the hull of these vessels. And now I believe we have another poll question for you to ponder, Charlotte.
Fantastic. Yes, thank you so much, Aaron. No, it's really interesting to hear about the different applications that that composite repairs can be used upon. So yeah, no, thank you so much for that. Right, so to move on to our next poll question, would your company consider using composite materials if you had a proven NDE technology for inspection? Now it'd be interesting to hear the results of this, and I'm sure hopefully it'll be a resounding yes. But yeah, we will see from the audience. So I'll give everyone a couple more seconds to vote, and yeah, just another encouragement to keep the questions coming in from the audience. I appreciate all the interaction so far, and there's definitely more questions coming in throughout the presentation. So yeah, we're looking forward to getting around to some more of those at the end.
Yeah, and if I can answer a couple more questions while we're waiting, if that's okay, Charlotte.
Perfect.
So one of the questions that came in from Corinne Hapuch Asirum, can your composite products be used underwater? So as far as the technology itself, so we have identified obviously several manufacturers of composite repair systems that are currently looking to do patch repair work underwater on the hulls of these floating vessels. And so we acknowledge and definitely that would be an area that eventually we feel the technology can be adapted for and be used for. Currently, though, we are not there yet. I think Aaron and I will get into a little more discussion. All those applications that you saw just now, we're kind of prioritizing them based on the less critical, I would say, applications, the ones that are easier to gain market entry into, if you will. So pipe wraps have been, used now for well over a decade, probably coming up almost on 2 decades in our industry. And so those would be kind of the low-hanging fruit, I would call it, where we can take this technology, go out there and identify what's the true serviceable life of these composite wraps that are already out there. Also, there's, a lot of interest in deck repair work on the top sides. So I would say getting into the underwater applications, that's certainly of interest to us and of our the operators and of the composite repair manufacturers, and eventually we'll get there. I mean, the technology I think is well suited to go underwater, but I would say give it a few years for us to develop it, because right now we're really focusing on those applications that are there's an immediate need for, and there's already currently quite a bit of composite repair work that's already been done out there that could easily benefit from these inspections.
Fantastic. Thanks, Vastan.
And I think I can see this as a in the future as an ROV deployable type of instrument, just like current UT gauges, and that can be integrated into small or work class ROVs. But right now, and Vastan will probably go over this, and I saw a couple of questions referring to kind of what the unit is, and right now it's just a handheld unit, hooks up to a laptop and some other equipment, but it's very much Pelican case. Can take it offshore to helo. Our goal is to actually be able to kind of, put it on an airplane in the overhead bin. That's how portable we want this thing. So, I mean, less than 40, 50 pounds. But I saw a couple of questions referring to, kind of what the equipment currently looks like.
Yeah, sure. Fantastic. Okay, well, our poll results are in, so I will share those with the audience. So it was as kind of hoped, a pretty much resounding yes. So 97% of the audience, their company would consider using composite materials if they had a proven NDE technology for inspection. Was that what you guys were expecting?
I mean, it was certainly what I was expecting, but I think even more so for the composite repair manufacturers out there, I think they're probably jumping up and down in their chairs right now going, yes, this is exactly what we were hoping for. So, but I mean, based on our previous conversations, I think this is exactly where the industry, what we need in order to advance composite use in our industry on a much broader scale. And so I think almost everybody from the composite repair companies would agree with that and are probably very happy to see these results.
Fantastic. Okie dokie. Well, without further ado, I will share back the screen. So we have a couple of discussion questions here that we'd kind of suggested in advance of the session. There are also a bunch of questions coming in. So Vastan, would you like to move forward with the discussion questions or go back into the PowerPoint?
Sure. No, we can definitely jump into the discussion questions here. Let me. So first, are there any other applications not yet discussed that should be considered for composite repairs? This is one of the things that, obviously, if you can post it in the question and answers, that would be helpful to us, because right now, I mean, most of the dialogue we've had has been with the composite repair companies, primarily 4 of them for offshore applications, including operators, obviously, of a lot of these floating production facilities. So, as I've said before, the drilling companies we haven't approached yet. And eventually we will. And there's probably other markets there too, and other applications that we're just not seeing. So, this is going to be, something where I think I mean, you're only limited to your imagination. Obviously, the economics have to pan out too for each application. To make a good argument for it, it has to be something that makes economic sense. Good business sense. But if there are any other applications besides, the helidecks, deck overlays, hull repairs, things of that nature that it can extend the life of these assets to use them for much longer. I mean, because these are, you're typically talking about billions of dollars for any, large offshore floating production facility. So getting an extra 5-10 years, and if composites can help you, I think, that's certainly a win-win for everybody. So please let us know if there are some other applications that we have missed. The second question, is it more difficult to receive regulatory approval for some applications of composites repairs over others? And I think right now we're still kind of in the infancy, but this is something, more of where, it'd help, gaining more insight from the operators. What have their struggles been, whether it's, preparing a DWAP to go to BSEE with, or any other regulatory body. I don't want this to sound like this is just centric to the Gulf of Mexico, because it certainly isn't. I mean, this is a global industry. So, this is, it could be the North Sea. We're talking about offshore Brazil. We're talking about offshore Australia, Asia Pacific. So, it would be helpful for us, because we understand that, even though sometimes we'd like to think that the Gulf of Mexico is the center of the oil and gas industry for offshore, and that's certainly not the case. So you have a lot of other regulatory bodies out there that we maybe are not cognizant of what their regulations require in this area. So it's always.
I think it's also risk-based, Vastan. Sorry for interrupting, but I
no,
think it's also
you're right.
Yeah, yes. I think it's also risk-based. So if it's structural repairs, right, that's probably going to take a little bit more time, a little bit more testing, yes. A little bit more validation to get buy-off from some of the regulatory approvals. But as far as deck plating, high-pressure piping is on the same vein, right? Anything that can cause some pain and suffering and damage, very very catastrophic damage, then that'll be a little bit longer, I think, for the regulators to buy off on. But, if we start off with the basics and kind of move up to there, I think, I could definitely see that in the future, that acceptance will be there.
Absolutely. And that's a great point. So going back to those applications we discussed earlier, the reason we put Helidecks on there, we kind of had that listing of deck repair and then pipe wrap, is the way that we're approaching this with the industry, working with the operators and composite repair companies, is we're trying to identify what is the low-hanging fruit, what are the things that have the lowest risk for basically related to anything for health, safety, and the environment, that could negatively impact it. And so Helidecks is that to me is, an area that we could start with deck repairs that we think that the regulatory authorities would buy off on probably much easier. And so that's kind of the approach that we're taking. I appreciate that. That's very, very good point, Aaron. I mean, we're really looking at this from a risk perspective. So we're probably focusing initially on the applications that are less likely to have any negative impact on HSE, and then work from there to get to the more critical applications, high pressure piping and things of that nature, to qualify the technology. Yeah.
Fantastic. Thanks, Vastan. I've just moved on the slide so we can run over the benefits, sure. I think, of composite.
Absolutely. So this right here is based on some of the preliminary validation testing that we've done. I cannot share that detailed information with you as much as I would like, since we are under NDA, but I can at least tell you what we have successfully validated the technology for. So once again, some of this we've already covered. In fact, I think most of this we've talked about, but I'll go into a little more detail and answer some of the other questions in relationship to this. So carbon fiber and e-glass. Once again, I know there's aramid fibers. I know there's other types of fibers out there. Right now, to date, the validation testing has been done only with carbon fiber and e-glass over multi-layered over a steel substrate. And so that's where we're at today. That does not mean that the technology possibly doesn't have applications or couldn't be used for other types of multi-layer composites, or, as I've said before, the technology was originally developed for aerospace. So we already know that it has success in reading or detecting defects in homogeneous material. So we're talking about, the heat shields. I can't even guess what that composite is, but that is a homogeneous structure as I understand it. So, density, I know has come up. I don't know if it came up in one of our questions, but it's come up in previous questions from other operators. Is there a limitation on the density? I would say as long as it's not like a foam board or something that has a lot of air entrapment, we should not have any issues with this technology in terms of reading through it and finding those any of the voids or defects. As far as the technology, one of the other key drivers and benefits that we found with this technology is all done in real time. This technology actually, the part of the key of the IP and the intellectual property is the algorithms. They are the physics-based algorithms that they're using, that the scientists have developed, and this technology is really, is kind of the heart of the technology and why it works so well. Are those algorithms and their efficiency in processing that data. So as you're taking the UT transducer, and that's the beauty of it, we can use virtually any UT transducer. I mean, once again, we can, right now we're primarily using, and to my knowledge, we're only using longitudinal wave transducers, but you have, all kinds of torsional, pitch. There's, like I said, almost a couple of dozen different types of wave generation and transducers that gather that data. Well, the nice thing is all this is processed in real time, and it shows you a real live image as you're scanning the material over the substrate, which is beautiful. And so that gives you a visual right away. So basically you're taking a two-dimensional method and it's giving you a 3D perspective in essence, because you're able to see not only the defect, but it's telling you where the depth of that defect is, which is critical. That's where I think some of the previous, as I've mentioned before, the previous UNDE technologies have fallen short, is they could not tell you precisely where the depth of that defect is. And as most of us know, that a defect in the surface layers, it probably isn't quite as critical as that defect at the substrate layer. And then as far as the actual details that it shows, size, shape, depth, all that's, there's nothing left to the imagination. I mean, I compare it to almost like an MRI, of your brain, or an MRI of your body. I mean, the doctors, it really gives you a true sense visually, internally, what's going on. And that's exactly what this does. It's almost the MRI for composites is the way I describe it, right or wrong. The location of the defects, that's the thing that we're working on now. So one of the things I want to point out is that we don't have, we haven't validated this for every application. I've had several operators ask, well, can you find underlying defects in the substrate itself, the steel substrate? If, in some of these situations where certain patch systems, let's say for example, pipe repairs, it's not uncommon if you have a dent to go ahead and to use a filler, and then you wrap the the composite wrap, the e-glass or whatever it is, around that filler that you've filled in that dent with. And so the answer is that it can, or it should be able to. We still have yet to do some final validation, but we have been able to read through multi-layer composites such as e-glass and carbon fiber and find holes that were pre-drilled in the actual steel substrate itself, and it'll measure the depth of that hole. So that means that we have the ability to understand what the underlying defect looks like in the steel substrate, but that's a hole. Now, some questions have come up. What about cracks? That we have not answered, and I'm not going to propose that we can find microscopic cracks or where cracks starting to propagate. Obviously, these are questions that we'd like to have answered at some point, and we plan to. But once again, I mean, we have just begun more or less the validation of this technology, and it's very encouraging in what we're seeing so far. And then of course it can, and we talked about this before, it can detect this can actually read through multiple inches. I mean, we're not talking about just a mil or 2 mils. We're talking about 30 plus mils, several inches of composite material, multi-layered and homogeneous. So that's another key attribute to this technology, is that it actually has the ability to read through several inches of composite material.
Fantastic. Thank you so much, Vastan. That's marvelous. So what we're moving on to now, we've got a kind of the final question block, but also there are certainly more questions coming in from the audience. And so if you'd like to perhaps go to the audience questions first, I'm aware we've kind of only got 10-15 minutes left in the hour, and I'm aware that's kind of what people have blocked out the time for this. So if you'd like to go to the audience questions first, that's totally up to you.
Yeah, let's go through some of the audience questions, because obviously, I mean, we want to make certain that we've got these answered. So let me go through here.
Oh, and also, I suppose, just on the audience question, something to note as well. ABS Group, I'm sure that Vastan and Aaron and the team at ABS will be happy to follow up kind of individually if there's questions that we don't get to afterwards. So I can definitely loop people in touch afterwards. So do drop me a note if your question doesn't get to, and I'll share the questions with Vastan and Aaron as well. Anyway, sorry, I'll stop talking.
No, not at all. Yeah, so here's a question from Tushar Padar. How about cost comparison over conventional traditional material? So once again, I mean, the UNDE technology itself, I think, is really, it in the sense it is an enabler. It will enable us to use these composites, I think, on a much larger scale for a lot of these previous applications that we've talked about. As far as the actual cost comparison, what does it cost? What's the advantage of using composite repair over, say, conventional steel for steel type repair? We've already talked about, or Aaron had mentioned it earlier, by using composites, obviously, if you're in an offshore environment where you're producing hydrocarbons, you don't have you don't need hot work permits. You don't potentially have to shut in production or anything of that nature. So I can't speak exactly to the economics because obviously it's going to be a little bit different, or it's going to be very different potentially for each operator, depending on the level of production for that asset, as well as what type of other metrics that you take into consideration. I can tell you, however, that almost every operator and everybody I've talked to, there is no question that using the composites for deck repairs, pipe repair, rather than replacing the pipe itself, is definitely much more cost efficient and economic than if you were to replace it with a whole new steel pipe or do a deck overlay, steel deck overlay. And then on top of that, the other nice thing about the composites is the weight compared to steel. You're not adding any additional weight to your top sides. And when you're talking about a floating asset, I mean, that's huge, because now you're not potentially affecting the center of gravity and its buoyancy, and you're not limiting its capability for deck load. If you've got risers or drill pipe or whatever the case may be for your application. So I would say there's a lot of economic advantages to using composites, but once again, that would be more of a question for yourself, the operator, and maybe even the composite repair companies to do those types of economic studies. But hopefully that gives you a little bit of insight based on my perspective from talking to the operators and composite repair companies.
And here's one from Jean-Philippe Court. It's an interesting one. It seems that this inspection technology may compensate for the classic lack of reliability of bonded composite repair in marine environment. What would the inspection frequency acceptable by class then? So that's our goal, Jean-Philippe, is to work with the class societies, of course, starting with the American Bureau of Shipping, since they're our parent company. But that would be something that you go into it, and maybe that becomes the normal hull inspection criteria, right? So as long as you understand what defect is acceptable, then you could put that on your typical hull inspection plan or whatever that is, and it shifts to that time frame now. So, but that's what we need to work with, the composite repair companies, the regulators, and the class societies, in such a thing as a joint industry project, on what is acceptable, again, what is not, and then what can the inspection frequencies now become. Hopefully that shifts from annual to every 5 years or whatever the typical, inspection frequency is for that. So that's kind of the goal, is to reduce that inspection frequency, right? That's the whole, that's one of the big goals that we'd like to see, of course. And I think the owner operators would like to see that as well, right? So less time for inspection, more time for actually earning money. Yep.
No, that's great. And then another question that I'm seeing here is from Rashan Amasur. Is this an ABS proprietary technology? So we do have the exclusive license to use this technology globally for offshore marine. So I don't know if that answers your question, but this is a technology that we have exclusive license to, and we are in the process of commercializing, as I've said before. And then we have an anonymous attendee. I'll try to get through as many of these as we have with, in fact, you just tell me, Charlotte, when we're out of time here.
That's fine. We've got 8 minutes left. So no, I'll let you guys crack on. Okay.
So from an anonymous attendee, how do we determine maximum internal pressure of a pipeline at repaired location using this wrap? If used underwater, can we determine collapse pressure at repair location? So once again, I mean, this UNDE technology, it's a great question. I mean, this is going to be able to tell you if you have a void, a defect of some sort, disbondment, delamination. Now, as far as determining the internal pressure, I mean, you have a lot of engineers and professionals out there that are well versed in fracture mechanics and understand how the different composite technologies work in their ability to hold the pressure. In fact, actually, there's been a lot of testing, particularly from the midstream in the last 15 years for our friends on the midstream side. And I know PHMSA and some other regulatory bodies have been heavily involved in that. PRCI has had a lot of studies that they've done. And so they've addressed a lot of these questions already on the midstream side and using pipe wraps and how that can influence or help rather, the pressure rating on these pipes. So I would say that's probably not an answer that I can give to you, but hopefully, I've given you enough information that maybe you can reference some of these other studies that have already been done by these other companies. And obviously any of the composite repair companies that are out there should be able to answer some of these questions for you or point you in the right direction. Yeah. Let's see, another question. It says here from Anil Prathura, what is the range of a single scan in terms of the distance of an identifiable defect? How does this change with different defect types? Yeah, so once again, so as far as the range of a single scan, that's going to be completely dependent on the transducer head, the size of the transducer head. And that's one of the, that's what we're working on right now is the commercialization. So we've already validated it, like I said before, for e-glass, for carbon fiber. And that was basically just flat, plane. And now, obviously, what we're doing is we're looking at how do we commercialize it for each one of those applications. Some of those like deck repairs, you're going to need something larger than just a handheld transducer that's the size of your mouse for your PC. So that is where what we're working on right now is identifying the correct size of transducers, possibly multiple transducer head assemblies. Some of them will be roller type, and that is where we are adapting the technology for each application. And a lot of it's going to be dependent on optimizing the transducer head setup. And in some applications with tanks and things of that nature, we may even have to, I can say that we probably need to look at a tractor setup, some kind of robotic tractor setup. And most of that technology has already been developed and is already deployed in our industry already. It's just a matter of retrofitting it to some of these unique, systems that are already out there. So that's what we're currently working on, but no, great question.
And our plan would be to also, if we could, get a sample of the composite material, over the, whatever the substrate that we're overlaying it on. So the I guess ultimate process would be to be able to get a sample of that. We could take it, we could calibrate the instrument, calibrate the algorithms, for that, so because different material densities are going to affect the scan. So, but yeah, that's something that we're going to have to probably execute on most of the projects, try to get some kind of sample and then, calibrate the tool onshore or, wherever in a lab first, and then kind of take it to the actual project execution area.
Yeah, absolutely. So some other questions here. I've got one from, let's see here, and I apologize if I don't quite correctly pronounce your name, Jeroen van der Heijden. How much experience is being drawn from the aircraft industry where composite repair has been around for quite some time? I would say that all of this is all centered around, this technology was developed originally for NASA and also for basically the U.S. Air Force. So the technology definitely it comes from that industry. So a lot of the even the transducers, the actual calibration and all those techniques and everything, I would say it has come 100% out of the aerospace industry. So, I mean, great question, but yes, aircraft industry, aerospace industry, that's exactly where this technology has come from. And that's the great thing about this. There's so many technologies out there. In fact, one of the things that really surprised me going back a few years ago is I was looking at, and I don't remember exactly the website, but I was looking at patents for new technologies just in the last year for different types of NDE, different types of scanning tools, things of that nature. And it was remarkable globally. It was, I think, almost an average of 100 different applications per month. So you're talking about thousands per year. And so the real, the hardest thing for me is when you're trying to identify these technologies, and a lot of them come from aerospace, some of them come from other industries, is which ones have the propensity or the best, potential for being commercialized. Because one of the nice things about this technology is it's real time. It doesn't require a huge CPU time or post-processing time, and it's portable. So, you have something now that you can literally take into almost any industry, because one of the previous questions I saw, and I apologize, I don't have the name of the individual in front of me. They asked if you can use this for offshore wind turbine blades. Absolutely. The technology has there shouldn't be any reason why you can't. It's just a matter of whether or not you're doing it in line with when you're manufacturing it, or if this is going to be something that you want to use offshore. And then it's a matter of, once again, how do you commercialize it? How do you, create the rigging and the tools that allow you to economically scan the turbine blades and things of that nature? And that's really what we're working on now. So we know we have the tool, we have the right tool. It's been validated. It shows that it can find the defects. It's now just a matter of making the investment to get the proper transducers and the head assemblies and everything set up and calibrated correctly. And that's what we're working on for each application, and to make sure that it's commercially viable. Yeah. Let's see. Do we have just a minute? I don't know, Charlotte. I think you're going to want to. I can see you popped up, so you might as well just cut me off now, because I could probably go on for another hour or so.
Okay. Well, no, fantastic. Yeah. Unfortunately, that's all we've got time for today, and we've got to wrap up because I'm sure people will be flying off to other meetings. Yeah, there's a huge number of questions and people requesting information. So both Aaron and Vastan, I'm sure, will be happy to follow up with individuals after the webinar. I will share all of the questions with Aaron and Vastan, and also do let me know if you'd like to be put in touch directly with ABS Group, and I can coordinate that. I mean, certainly I've learned a huge amount today, and there's clearly huge benefits of using composite repairs for both extending offshore asset life, but also amongst a huge number of other applications in other settings. So yeah, that's hugely appreciated, and I'd like to thank Vastan and Aaron for participating today. I'm sure that the audience has found the insight valuable.
And I believe we also have an overview of the application, something that we were going to provide, I think, as well. So if you needed additional information, that'll be made available to you.
Fantastic. Perfect. Yes, so I will send that out, and also you will have full access to the audio replay and presentation, so please kind of share them with colleagues, clients, and the community. We want to spread the knowledge in this area as much as possible. So without further ado, I would like to thank you both so much for joining.
Thank you.
And thank you,
very
Charlotte.
much appreciated.
Thank you for hosting.
Yes.
Thanks, you. Have a good day all.
Thank you.
Ciao. Bye.